The universe does not follow laws the way you think. We often speak about the laws of physics as if they were rules imposed on reality, as if the universe were following a script written somewhere outside itself. Objects move because they must. Particles behave because laws command them to. Reality appears disciplined, obedient, governed from above by equations that decide what can and cannot happen. Physics does not actually describe the universe this way. The idea of laws as prescriptions is a human habit, not a physical necessity. Nature does not consult equations before acting. Equations are written after patterns are observed. What we call a law is not something the universe follows, it is something we infer. This distinction matters. When physicists say that a system follows a law, what they mean is that its behavior is regular enough to be described consistently. The law does not cause the behavior makes the law possible. Laws are summaries, not commands. This reverses intuition. Instead of laws shaping reality, reality stabilizes into patterns that we describe as laws. The universe does not obey equations. Equations adapt to the universe. This becomes clearer when we examine how laws change. Classical physics once described motion perfectly. Then relativity revealed that those laws were approximations. Quantum mechanics revealed deeper limits. The laws did not break, they stopped applying. New regularities appeared where old ones failed. If laws were absolute rules, this would not happen. Rules do not partially apply, but patterns do. Physics advances not by discovering eternal commands, but by refining which regularities hold under which conditions. Each theory works within a domain. Beyond it, the pattern changes. This suggests that laws are contextual. At human scales, objects behave predictably. At atomic scales, probability replaces certainty. At cosmic scales, space and time bend. Reality does not violate laws, it shifts regimes. The universe is not governed by one set of rules. It exhibits layered regularity. This layered structure tells us something important. Necessity is not universal. What must happen at one scale becomes irrelevant at another. Determinism dissolves into probability. Stability dissolves into fluctuation. The deeper physics goes, the less law-like laws appear. At fundamental levels, equations describe constraints, not outcomes. They tell us what cannot happen, not what must. Many futures remain possible within the same physical framework. The universe does not select one because a law demands it. It selects one because interaction resolves uncertainty. This changes the meaning of explanation. To explain something is not to point to a law that forced it. It is to show how the event fits within a allowed structure. Physics does not eliminate contingency. It contains Italiano. The idea that everything happens because it had to is not supported by modern physics. What physics supports is consistency, not inevitability. This has consequences beyond science. When laws are seen as descriptions rather than proscriptions, reality feels less rigid. The universe is no longer a machine executing a program. It is a system maintaining coherence across countless interactions. Order exists, but it is not imposed. Structure exists, but it is not commanded. This view aligns with how complexity arises. Patterns form spontaneously when conditions allow them. Crystals grow, galaxies form. Life organizes. No law instructs matter to become complex. Regularities allow complexity to stabilize once it appears. The universe does not aim. It permits. Physics, then, is not a list of rules. It is a map of permissions and constraints. Within those constraints, reality explores possibilities. Some persist, most vanish. What remains looks lawful only because instability does not last. This reframing softens the desire for ultimate explanation. If laws are summaries of behavior, then asking why this law becomes meaningless. The more relevant question becomes, under what conditions does this regularity appear? Physics becomes conditional rather than absolute. This also explains why unification is difficult. We expect one law to rule all scales. Reality does not promise this. Different scales stabilize differently. Expecting a single framework may be a projection of human preference, not a requirement of nature. When this is understood, the universe feels less constrained and more subtle. Predictability remains where it works. Uncertainty remains where it must. Neither is fundamental everywhere. The universe is not ruled. It is structured, and structure does not need authority. It only needs consistency. Physics does not tell reality how to behave. It learns how reality tends to behave and where it stops being predictable. This is not a loss of order. It is a deeper order without command. When we stop imagining laws as rules, reality becomes easier to face. Not because it becomes simpler, but because it becomes more honest. The universe is not obligated to follow our expectations of necessity. It simply continues, structured enough to exist, open enough to change. And physics, at its best, does not pretend otherwise. Still, within